Hey guys, Caitlin here with lesson 8 and lesson 7. I think they're on the same page of your homework packet this week. And they're hanger diagrams. Is what we did in class on Tuesday. So both of these can kind of be summed up in just a few problems. We're solving these equations using these diagrams to help us reason through it. You don't have to use the diagram if you have other strategies. We're going to learn more strategies this week. But the diagram is a good visual to help kind of get you on the right track. So let's look at this first one here with 7 equals 2x plus 3. We've got 7, 1, 2, 3, 4, 5, 6, 7 blocks on the left side. That's what that 7 represents. We've got two unknown things, which we're going to say are the circles, 2 x's, and then 3 things that we know. So I guess what we're thinking here is the squares are equal to 1 in value, and we're just trying to find out what the circles equal in value. So a way to get this isolated where we're just focused on the circles is to take away 3 from each side. And by doing this, it's going to stay level. It's going to stay balanced. And if the 3 disappears on the right, you're left with 2x. And you take away 3 from 7, you have 4 left over. So 2 circles are equivalent to the weight of 4 squares. So that means that every circle has a weight of 2 of the squares. So every x is worth 2 when you solve those. So that's one way to think about that. There's other ways to solve it and find out that the circles are worth 2 squares, but that is where we're at here. So let's look. I don't know why that's number 2 and we skipped number 1. I must have taken one off because I didn't like it. Let's look at the third numbered problem on this page for lesson 8. We have a hanger model, and we're needing to write an equation for it. So let's knock that out first. So an equation for this would be 1, 2, 3, 4, 5 x's plus 2 extra on the left side of the equals. And on the right side of the equals, we have 17 in worth. So as we work this out, we're going to first of all take the 2 off, right? And by knocking 2 off of this, that's going to change this weight to 15 now, right? And so 5 x's are worth 15 amount of value. And so that 15 needs to be divvied up into 5 equal sections, divvied up into 5 equal parts, 1, 2, 3, 4, 5. And if they're all equal, then they should be worth 3, because 3 times 5 is 15, right? So every part is worth 3. So if 5 x's are worth 15, then every one of those x's values is worth 3. And that's how we solve those. Draw more hangers to show each step you would take to find x. Okay, so I guess this represents the original hanger. This hanger could have been shown by drawing something like, all right, I've got 5 x's, 1, 2, 3, 4, 5, and they equal 15, right? And then the last hanger could have been drawn to show that every one of those is worth 3 in weight. So you can think of it like that. So hanger, 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 3 hangers to represent my steps along the way. Write an equation to describe each hanger that you drew. We kind of already did that as we were going along. And describe how each equation matches its hanger. I think that was kind of done as I was explaining that. So I'm not going to expect you to have that description unless you just want to. I feel like that's just a bit of an overkill. Let's go to lesson 8. All right, lesson 8, I tried to have you do these in groups instead of having them just yanking off amounts on each hanger. So notice the dotted figures that are enclosing these into groups of however many. So in this particular one here, since I have these dotted groups of 1, 2, 3, 4, 5, I've got 5 things. This is part A. I've got 5 things, and those things are made up of x and 2 being put together with addition. So I've got 5 x plus 2s. 1 there, 2, 3, 4, 5. And whenever those all come together, it makes a total of 11. All right, so this is my equation. Now it says solve the equation by reasoning about the equation or the hanger. So you can reason about it by drawing on this, or you can reason through this over here. Okay, so if 5x plus 2s are worth 11, then a single x plus 2 will be worth 11 divided by 5, because that 11 needs to get cut into 5 equal spaces, right? One for you, one for you, one for you, one for you, and one for you. 5 equal parts. Now 11 divided by 5 turns out to be 2 1/5. It goes into this twice with a fifth left over. So x plus 2 is actually equal to 2.2. Okay, 1/5 is 0.2. Okay, you can divide that out in your calculator. Just do 11 divided by 5, and you get 2.2. Okay, that's where that's coming from. And what number can I add to 2 to get to 0.2? Well, that's pretty simple. Every one of these x's is worth 2/10 or a fifth. Every one is worth a fifth. So that's the answer for part A. We solved it. I feel like we did a good job of explaining and showing our work along the way. Last one for this page. You have to explain how each part of this equation is represented by this hanger. Okay, so we just got to write some words here. The x in the hanger and in the equation represents the unknown value. Okay, as always for variables. All right, it represents the part that we don't know. It's unknown value. Okay, now the next part here, the 9 is represented as the total on one side, right? There are 9 ones on one side. It's the total. So all of these things equal 9 when added together. It's the sum. You could even write sum if you wanted to write that. Okay, the next one, the 3. Now, you don't see a 3 particularly in this problem, but the 3 relates to the number of figured groupings, right? So this is the number of groups, the number of groupings, the number of dotted figures that we've grouped this into. They're identical groups. Now, the x plus 2 is representing what is in each group. So the value of each group. In every group is an x plus 2. X plus 2, x plus 2. And then lastly, okay, the last thing, 3x plus 2s represents the total on one side. Again, but this is on the other side, right? Hence why our equation says 9 equals 3 times x plus 2, because they are the total for the left and the right side. Thus, they should be equal to one another. And the equal sign shows that they are in balance. They are balanced. Or it's the same on each side. Balanced. And that's it. That's all of this page for the third page. The next video will cover lesson 9, where we talk about negatives.